Restart.
Restart.
Darren, every time.
Awesome.
Every time.
Buddy waited for it.
Logan, 1 through 4.
2.
Wait, there's another
Three.
pocket here? Jackson, look at there's a pocket. Oh my God.
So what does that give, Devin? 1, what did you say?
I said 3.
1, 3, and 4?
He gets 4.
I
One,
guess we
1,
get
2, and
two.
3? Roll.
1.
How can you tell always ever towards the top?
Skedaddle.
Are we not number 2?
We're number 2.
We're number 2, you're number 1.
You got perfect space, you get the one.
Oh, I thought we had number 2.
We are number 1. Alright, RoboMaster, Zeta Parker. RoboMaster has one. L1 RoboMaster has one. Search and rescue with scratch programming.
Our challenge is to program the RoboMaster S1 to search for a person and alert when he/she is detected. We'll be able to complete our goal because we have all the needed ways. Yeah. Anywho, we reach our goal by doing something different every day, such as trying the software and the robot on day 1 and trying to accomplish something different on the other day.
About our technology is a programmable robot that is controlled by an app on an iPad. The RoboMaster is a robot with omnidirectional wheels and jelly blaster on the top. The controls on the iPad have a lot of variability, like having gyro control setting and controlling all the speed modifiers. The app also has a coding mode and a battle mode where you can make the robots fight.
Our robot. Robot in the real world can be used to help people in need, and so can the real world robot.
What did we learn? We learned a lot about how to work the basics of the robot. For example, we learned that you were able to record audio through the iPad and play it through the robot. We also made gel beads and shot them all over the place. We were able to record videos and record the audio.
Problems that we have? Anywho, cool features. Audio recording and playing. You can record the audio with a microphone on the iPad and play it on the robot to other people. It is also a lot louder than you think. Also, apparently, gel beads. You can make little beads that you can shoot out of a barrel. Router connection. If you connect to a router in a big building, you can go as far as the router allows you to go in the building.
With your router.
With
Programming. In the RoboMaster app, there's a section dedicated to block coding, as seen in the picture below. You code the machine by putting the blocks together and telling the robot what to do in a specific order. This is a more simplified version. This is a more simplified version of normal coding.
My experience was very mixed. I figured out the audio recording part of the RoboMaster app and used it in a way that some would find funny. I also was the first one to start coding, which I didn't really understand. It was the 4th day, so it was harder to comprehend with 15 minutes left in the day. Should have started it earlier, but my favorite thing I did in these 4 days was use the audio recording and shoot the gel beads.
My experience was pretty good. I had fun doing all the parts of the launcher and the parts we did on our own. I learned about the RoboMaster and the controls, as well as how to put the battery in and the gel bead magazine. My favorite part was driving the robot and shooting gel beads around the room. The beads are degradable, and you step into the carpet and they go away.
Brooklyn was new in this class, and she just kind of hitched onto us. She was only around for the last 2 days, and she said it was a very interesting experience. She thought that the programming would be more difficult, but it was fairly simple.
challenge is program the RoboMaster S1 to search for a person and alert when he/she is detected. We didn't really do that, but you know, we think that we half made our goal and half didn't make it because we started a little on coding, but didn't get the robot to detect someone in that way. We did, however, scan people and follow them around without using the controls on the robot. Probably wouldn't do it again because the coding can be a little confusing. We liked that the launcher was easy to understand in the way of like controlling the robot and shooting the beads out of the robot and stuff. We had success with the gel beads and the audio recording part. We learned that you could have the robot scan someone, have the robot follow it, and we took turns doing different things on the robot.
Vocab. Omnidirectional. The wheels. Wheels that can go any way, so you can drive sideways, forward, any way. Gyro control. When you're using the iPad, you basically move the iPad and it moves the I don't even know what you call it.
The
gimbal.
camera. The gimbal.
This thing. Block coding. Simplified version of coding. Barrel. The part of the robot that can shoot laser beams or the white gel beads. Router is a device that provides Wi-Fi and is typically connected to a modem.
Was gyro control somewhere else in the?
Yes, it was.
Yeah, I didn't miss that word. Full slide. Don't save. Okay. So Logan, Morgan, pick your number. 3. Logan's got 2.
I
Devin's
got
got 1.
3.
Wait, so was there a 4 on that last one?
Yeah.
Oh, I didn't even see a 4 on it, but
D4.
you're a 4. I was driving in my car and car.
The Mechanics 2.0 Super Crane. By yours, Morgan. We will be using the Lesson 3 PhysiConnects Mechanic plus Static 2 Super Crane Challenge. Mechanics 2.0. And I will be using this exact launcher right here. My smart goal. Our challenge is to learn how to use the compound pulley system to gain enough mechanical advantage to lift a super heavy loads. My task is to build a model crane and modify it using principles of both statistics and mechanics to maximize the load weight I can lift. I'll be using the Mechanics 2.0 to make a super crane. The crane is a kind of powerful crane that is used in everyday life for construction. I will know when I'm meeting my goal when I get the top of the crane done and the tower that it holds the top of the crane and the motors that makes the crane run. I have all the needed resources like the Mechanics Book 2.0 and the parts needed for this project. I've wanted to build and work a crane and this is my chance to try something new. Day 1, I'll finish my smart goal. Day 2, I'll work on the base of the crane. Days 3 and 4, build the motors and the top of the crane up and running. About my technology. The technology I'm using is a Mechanics 2.0 and it's basically about trying to get people into doing construction. For the last couple of days I have been building, testing the super crane. The super crane is nice, but it has its limitations. It is nice for younger kids because it introduces them into construction and wiring and gears. This is the 3D image of a what a super crane would look like, and this is the crane that I built. As you see here, it's almost exactly like the crane on there. You can move it back and forth, the motors and everything work, and I'll elaborate how that was a challenge for me. Okay, what did I learn? Cranes are sophisticated compound machines that demonstrate several principles of mechanics and statistics. Statics. The mechanical aspects of a crane rely on pulleys, gears, and levers to provide mechanical advantage. Okay. Since cranes can lift heavy loads, they must be structurally stable as well. Size and weight are important designs, sophistications for cranes that move from one job location to another. These cranes are carefully engineered with complex trusses systems to provide structural strength. Trusses are the ones that are welded onto each side of the crane to provide a lot of strength and stability because they can go how high they want. What problems did I have? The problems I had was pieces that do not fit in the sockets, so I had to flip the pieces around to make it fit. The other problem I had was trying to get the slip joint. It would slip under load. I fixed that problem by getting a lock joint to replace the slip joint. There is a slip joint that's connected to this irreducted motor, and then the slip joint is right there connected to the wire. What did I learn in part 2? Pulleys perform an important function in all types of cranes. Pulley is one of the 6 types of simple machines. A simple pulley system consists of a rope, a cable, canal over a freely rotating wheel. A simple pulley changes the direction of force, but does not provide any mechanical advantage. The force necessary to lift an object is equal to the weight of that object. In order to gain mechanical advantage, the compound pulley system is necessary. By increasing the number of pulleys, you increase the number of loops of the rope or cable in your machine. This allows us to trade force for distance, the length of the rope, and reduce the force necessary to lift an object. The principle is similar to levers and gearing systems you may have used in learning projects. The other problems I had. The other problems I had was the pieces of the set were small and need extra finesse to get them to fit without breaking. The other problem I had was the supports were very hard for the crane, so I had to finesse my way for them to fit. One of the problems I had another one is about the trusses right here. It's structurally sound, but this one on the top would not fit because of this front brace bar. An exciting experience. Building the crane was nice and cool. Getting the pieces to work and fit was a challenge, but at the end the crane is done and ready to work. The other problems. The other problems I had were the crane would not lift anything, and I don't know why. The motor isn't working. I fixed this problem was the wiring was wrong, and they were connected weird, so I fixed that. Part 2. While building the crane from the ground up, it was cool because I knew that it would look cool at the end. Like, you get that feeling that as you're building it, you're saying, what about the next piece? Will it make it better? It's like Lego. Picture it as Lego. Conclusion. This is my challenge. Learn how to use a compound pulley system to gain enough mechanical advantage to lift super heavy loads. My task is to build a model crane and modify and use the principles of both statics and mechanics to maximize the load of weight you can lift. I didn't meet my goal because I got it done one day early. I would do this launcher again because it was cool building the crane. It was a pretty exciting experience. Things I liked about the launcher that it explains everything to you in like a simple manner. The main successes I got was getting the crane done early. I learned how to use, put shapes onto the slides, like up there. I did not have a partner though. I wanted to do this thing solo. Main detail is that it challenges you to make a more sophisticated crane. And here is my. Should I say this?
No, you don't have to.
But could I?
If you want.
Okay. I'm just going to rely this onto you. Compound machines is a machine consisting of two or more simple machines. Mechanics, the branch of applied mathematics dealing with the motor and forces producing motion. A pulley is a wheel that carries a flexible rope, cord, cable, chain, or belt in its rim. Gears, one of the set of toothed wheels that work together to alter the relation between the speed of a driving mechanism. Levers, a rigid bar resting on a pivot used to help move a heavy or firmly fixed load with one end when pressure is applied to the other. Mechanical advantage, the ratio of a force produced by a machine to the force applied to it, using and assessing the performance of a machine. Statics, the branch of mechanics concerned with bodies at rest and forces in equilibrium. Simple machines, any of the basic machines provided for applying force, such as inclined plane, wedges, or levers.
Okay, which number do you want? 1 or 2?
2.
Let it drop on the ground.
That's like a coin.
Here, let it drop on the ground.
Oh, let it drop.
Let it drop on the ground,
If
Devin.
you're flipping, they get to pick how. That's what is fair.
Let's go.
Alright.
Bang.
My goodness.
We know.
First time.
Yeah. Oh. No.
How many of these did you add? Oh no.
Okay.
6-foot Ferris wheel.
Part 1 is the Connects Thrill Rides 6-foot Ferris wheel.
Oh my goodness. No.
Our challenge is to build a functioning 6-foot Ferris wheel. We will use Connects to create a 6-foot Ferris wheel by following the instructions and putting the pieces together.
We will need approximately 10 days if all 3 of us work. This was as we had 3 people before, and now we currently have 2, so I have to put in some extra work. But hopefully we'll be able to get it done in this next week, and yeah.
Up. Our technology is something that is used to resemble a real-life Ferris wheel. It is something that is being built all around the world. Our technology is Kinetics, which is a simple kids building system, but the building processes resemble real-life structures.
Ferris wheel that we are building uses some of the same structural designs as a real Ferris wheel. In the real world, spoke cables hold the spokes in line. There are a lot of intricate pieces involved in the building of this Ferris wheel. With spokes, spoke cables are not involved.
So we learned that building very large objects, also known as 6-foot Ferris wheel, takes a lot of hard work and determination to finish. But we will use our communication skills to collaborate as a team.
What problems do we have? So, towards the beginning, we kind of read the instructions wrong, and we had to take a few pieces apart, and then we were able to put them back together using the problem-solving skills. And yeah.
On day one, we started to work on the base of the support frame, which is the
On day 2, we built off our base and continued to work on the supports.
what? Uh-oh. Gotta go that way. So on day 3, we prepared the support frame for the axle.
On day 4, we began assembling the spokes for the wheel, and eventually these will support the rim and the sightseeing cabin.
Okay. So our challenge was to build a 6-foot tall Ferris wheel, and we wanted to complete 50% of that, which I think we have managed. So we are on track to complete our SMART goal on time. And we got to the point, which was about 50% done, so.
Jackson,
Yep.
are you going to continue that next one and finish your Ferris wheel?
Kinda have to.
That's what we said we were.
Alright, Devin, what's your number?
1, 0.
Oh, no.
I got it! I guess Devin doesn't have to present?
Oh.
Yeah.
Somehow he managed to get the D1 to roll a 0.
Oh, good job, Devin.
Second time, I'm gonna have to,
Invest in a different D1.
I'm gonna have to complain. First 2 rolls.
Yeah, if you get a 0 2 times in a row, then you don't have to present.
Yeah, roll
The
again.
carpet just doesn't let it roll.
I think you're right.
Roll it again.
Roll again on the table.
Maybe it
Oh, roll it on the table.
Still, is that a 0 again?
No, it's
Side
kinda
to side.
in between.
The carpet don't let it do its thing.
It doesn't let it do its thing.
Doesn't let it do it.
Alright, come on, Devin.
Okay.
Get up there, Devin.
I still technically cheated in your guys' roll.
Huh.
Because when you have a dice high, it's actually a 51-49% chance.
Oh, really?
51% chance based on the side you look at.
Really? Oh.
Pretty sure it's 50-50.
Oh, so Devin cheated.
Oh.
Which means Devin gets 0 points. And Devin even admitted to his cheating.
Okay, maybe go
Oh, you
present.
got that thing there.
Devin, maybe go present.
Yeah.
Maybe go present now. Present.
CNC machine. My launcher is carbon create and carbon motion and motion. But this is a video. Can you play the video game?
You should be able to tap. Did you try tapping it?
Yeah, I did. This is basically a video of the same machine actually cutting. It gets a lot worse after. This makes a huge mess when it's done cutting.
She fills in one spot.
Moving all over the place.
Oh, there we go. Good angle. Good angle.
Yeah, that's just.
Mine remains.
Good angle.
My challenge was to make CNC G code and get the G code out of the thing. And apparently some of the G code was not working right, so I just look through it and see which G code was messing up. It's not fun because I had to find a G code thing and I found out what area it was, so it was around 1,180 around there. It was messing up. My challenge to make G code so I can start putting things I wanted to cut. Basically, I cut basically a square. So, I'll get it after. Next slide, please. Oh, whatever. CNC machine is made parts like pipes, bars, and sometimes to make toys for kids, like dice, or games, or you can make mini cars, action figures, whatever basically you want. I'll relate your watching a robot CNC. I mainly use like custom parts as they made it helps them very quick. This is a factory CNC machine line, and this is a CNC machine I used. These factory ones are a lot different because they don't just have the one axis they cut from, they cut from front and the side, so it kind of cuts a lot more.
Oh, now he's drawing.
I learned the CNC machine G-code can sometimes have errors, so you want to check that, make sure that it's correct if possible. Again, our person's opinions, who knows what they're doing about it, to see if you've made any errors. Or the machine has made any errors. What problems? Not being able to get the G-code affects them by getting the free trial of the Carbon Motion, like Carbon Crave, which it's annoying. Oh, this is some of the mess I made. That's only one of those. That's a picture of it after it was done cutting. It was just.
Is that an action shot? Oh,
These are just some of the pictures. What is going on? There, what problems? Is something wrong on your side?
Yeah, I'm clicking around everything.
Oh, what problems? I'm not able to get to G. Yeah, like G code and this is picture of part. Can you click next? This is basically some. This is the carbon front, and the jog is basically you set the 0 point and you set where your material is. Runs where you put the file for your G code, which will have the machine run it. And feed rate is basically how fast the CNC machine is going and cutting. Reset feed rate basically puts it back to what your G code has set it for, and feed rate and the max feed rate is making it slower. So next, this picture of it being completed. Next, this is pictures of it. Next, practice with the dock. Next. Oh, I forgot to take that off. I was able to complete my smart goal, which was to cut things out using the C machine. I love to do this again from that time. I think it's a great launcher and has a lot of fun, and it allows you to use your ideas and make it into by cutting out and closing that. I was able to get the G code by getting free trial. I worked alone, which helped me because I could focus on one thing and keep track. I only have to keep track one pair of hands. If you have two people, you have to keep track of two people's hands because you don't want someone else's hands when you're trying to use the card. Next. G code